Welcome back, everyone, and we are taking a look at service profiles, aren't we? We know that we have created some important resource pools. These resource pools can be put into service profiles, and service profiles are going to be hugely important because they're going to bring all of these pooled resources together so that we can literally have stateless computing. That's right. The service profile is going to make this stateless computing possible by taking all of the identity and policy information and abstracting it from our physical server. So if we have a compute node that becomes unavailable, we can just take the service profile, reassociate it with another compatible compute node, and the virtual machine thinks that it is running in the exact same environment. So we know the service profile is going to provide the identity and state information for the logical server, but here's something to think about. It's also going to define the LAN and SAN connectivity. Yeah, so these particular service profiles are also critical in that regard. So service profiles will accommodate the server mobility, right? We can do things like vMotion a machine from one blade to another thanks to the service profile. But keep in mind that even in environments where blades are managed as traditional individual servers, service profiles would still be required because they're going to define how the UCS connects to the LAN and storage area networking. So, the first aspect of this that we're going to take a look at is a BIOS policy. And we can create a BIOS policy in order to apply that to an appropriate service profile. So let's see the BIOS policy. This is back on the servers area, and it's underneath our policies node, where we were earlier, and notice there is a BIOS policies object, and we can create a new BIOS policy. In earlier versions of UCS, all you could control was the boot order, but now there are a wide variety of BIOS policy settings that we can control for our service policy equipment. Notice here I'm doing a vSphere Direct IO named BIOS policy, and we're going to configure things like quiet boot, resume AC on power loss, front panel lockout. And notice that the option in here of platform dependent means to go ahead and take whatever is set by the factory default. So if you say platform default, you're saying, okay, you're not going to manipulate it. You'll go with whatever setting is inside the factory defaulted equipment. Notice here we have plenty of options for the processor. Many of these are taking advantage of enhanced CPU capabilities, and many of the enhanced CPU capabilities were designed around data center types of environments. So here we are manipulating the processor BIOS settings. Here you can see we are able to manipulate Intel directed input-output options. And when we make all of these selections, and by the way, these selections are typically going to be made through you consulting with VMware or with Intel or both. So you don't just come in here and blindly start choosing these features. You choose these features based on the guidance of VMware and Intel. And that's a great question. Duncan says, well, what if these aren't supported by the underlying CPU? Yeah, great point. So you do have options that'll show up here that might not even be supported on the underlying CPU. So keep that in mind. This is not dynamically built based on the CPU you are considering. So that is definitely something to keep in mind. All right, well, once you create this BIOS policy, it will be in the appropriate organizational structure where you created it, and it is now going to be available for assignment in a service policy. Something else to consider is that we want an adapter policy as well. So once again, we go to the Servers tab, and notice there are adapter policies under the policies node of the servers area. So we might create a new Ethernet adapter policy, and this is where we can globally set for our service policy particular network adapter settings. Receive side scaling to enable it or not enable it, etc. So once you create your adapter policy, it's going to be available as well, like all the other policies that we've created. You can go in and you can create a QoS policy, a QoS system class. This is done in the LAN Uplinks Manager. So we go into the LAN Uplinks Manager off of the equipment area. And in the LAN Uplinks Manager, you can go ahead and click QoS, the QoS tab, in order to access a dialog box where maybe in this example, we are enabling jumbo Ethernet frames for a particular class of traffic. Here, the gold class with a COS marking of 4 is going to have jumbo frame support enabled. So we can go ahead and create a new QoS policy by choosing the particular area and then creating the QoS policy and then specifying the particular QoS policy that we are interested in carrying out. So BIOS policies, QoS policies, adapter policies, all have the ability to be created here. And again, these are all components that might make up our overall service policy. Remember that one way there was to manage your equipment? It was called the Intelligent Platform Management Interface. We said this was built in conjunction with Intel. Yeah, the Intelligent Platform Management Interface and your serial over LAN policies can be created so that management of your devices using something like IPMI can be facilitated. So that's another type of policy that we can create. As you can see on screen, the IPMI policy. Here you're going to create the policy by naming it, and you're going to have to create at least one user that you can log in as to go ahead and manage the device using IPMI. Once you do this, obviously that particular policy is available for assignment. Keep in mind that the users that you create in this interface for IPMI management of your equipment, these do not count against your 40 user limit that you would have on the local authentication database in the UCS system. So these don't count against your 40 user limit. How about the serial over LAN connectivity? Yep, you can create a serial over LAN connectivity. So you can go in and you can say, yes, I want to do serial over LAN connectivity. You can set the speed of the connection, and then this particular policy would be available. How about what's going to happen for disks that you're no longer using? This is called a scrub policy. So we can scrub disks that are no longer utilized. We can scrub BIOS settings that are no longer utilized. And you'll find this option under Create Scrub Policy. Here we can see on the first screen, we're going to give it a name and optional description. And then we are going to indicate whether or not local drives will be completely erased when they are disassociated from a service profile. And we're also indicating whether or not the BIOS settings will revert to factory defaults when we disassociate a service profile from a particular piece of equipment. Once you make these choices, of course, that scrub policy is available for assignment to your service profile. Now, there are two service profile wizards. There are two service profile wizards. There is the simple single-page wizard that allows a profile to be created, and then there is an expert service profile wizard. Big, straightforward difference between these two. The single-page form, the simple wizard, does not support stateless computing. So this is not what we would typically want to engage in. Yep, it's not going to give us all of the information, all of the resources that we would need in order to do stateless computing. So, the universally unique identifier would have to be derived, for instance, as opposed to utilizing a pool that we created. So the basic wizard would be for deploying a stateful compute resource. The expert wizard we would use if we were interested in deploying stateless compute resources. All right, well, let's see where these are, and let's see how we can use this wizard to create our service profile. If we go to the Servers tab and we go under Service Profiles, we can choose our particular organization, and then over on the right, we can choose to create a service profile. And notice the one we are interested in for statelessness is called Expert. This is the other one-page service profile that I mentioned to you that does not give you the statelessness. We come in, and the first thing that we are asked to do is name our service profile. And then notice we're going to go ahead and we are going to select the pool that we created earlier for universally unique ID assignment. Notice, pretty interesting, if you did not create this pool earlier, we do, as luck would have it, we are given an interface right here to create it. So pretty cool. If we forgot to create a component in the service profile, then we can go ahead and create that component right on the fly. So here we can see they're going in and they're creating one right on the fly versus assigning one that's already been created. Here you can see we're assigning one that we created earlier, of course. And that's just simply selecting it from a list. All right, how about our virtual host bus adapters? Yeah, no problem. We went ahead and we created a pool for the SAN connectivity naming, and we can go ahead and select that pool in this wizard. Notice we're just going in here and we are selecting those resource pools that we created earlier on, right? We go in and we assign the appropriate pool to the storage resource. We create a virtual host bus adapter for Fabric A. Again, we can go ahead and select the vSAN here. We can pull the worldwide port name from the pool that we created earlier. We're then going to use the wizard to create the virtual host bus adapter for Fabric B. And then we'll go ahead and configure the simple networking wizard page. So we'll see that we have a simple view on the opening pages of virtual NICs for their configuration. We can go ahead and select the VLAN. We can select the MAC address pools, etc. By the way, if you need to see more options for networking, you can switch to the expert view of networking, which will give you even more options to configure in the service policy. Here you can see we're defining the properties for a new virtual network interface card that we're going to be utilizing in our infrastructure. Here we're defining a card for Fabric B. After we're done designing the virtual NICs, we see a summary of the virtual NICs that we are configuring in this particular profile. Here we're seeing that the full slot blades have their 2 mezzanine cards. So we can go in and define the VNIC and virtual host bus adapter for these machines with multiple virtual NICs. Then we can control boot order in the service profile. Yeah, so what's the exact boot order? We're going to boot from storage, boot from CD-ROM. How is that boot order going to be accomplished? And we can go ahead and set that up here in the service profiles creation. Here you see a pop-up window appears, allowing us to set the VBA as the primary or secondary boot device. Here we demonstrate on Fabric A setting up the virtual host bus adapter as primary, and then over on Fabric B we set up the VBA as secondary for Fabric B. Here we're setting the particular boot target. And then we get an order summary screen, and we're good to go. Now, how about server assignment? Well, we could select a server pool, right? We could say, yeah, well, for servers that are going to be pulled for this particular service profile, go ahead and use the pool that we created earlier. Remember, that was a pool that was going to be dynamically populated. Or we can go ahead and apply this service profile directly. So we can see a list of servers that are available and not identified with a service policy, a service profile, excuse me, and we can go in and associate them. Notice the last section here of this list of things we do to create a service profile is our catch-all operational policies. Here's where we can drop in the IPMI profile we created earlier, the serial over LAN profile that we created earlier. Notice monitoring thresholds, BIOS configuration, our scrub policy. All these odds and ends can be tied into the service profile at this point. Notice, by the way, that a lot of these are optional. I mean, when it comes right down to it, the only mandatory ingredients are a universally unique ID and a universally unique MAC address. Those are the only absolute required components in a service policy, a service profile, excuse me. But notice that we often do take advantage of lots of the optional components that we can create this way. Now, one of the cool things that you're aware of already that we can do here is we can create a service profile template. And then from that particular template, we could create a clone in order to quickly deploy resources. So this is what we're going to wrap up with today. Very, very easy. And I won't even walk you through all the screens because there'll be a repeat. Okay, we're not going to repeat all those screenshots. But what we're doing here is we're going over to the Servers tab, and we're choosing Service Profile Templates this time. And then we can create a new Service Profile Template. How awesome. And this, of course, starts a wizard that's going to have us build the template. Notice it's going to look just like the screens that we saw for actually building the service profile. Now, there is one thing I wanted to point out to you, and there's one unique choice here, and that is this going to be an initial template, or are we doing an updating of a template that is already assigned out there to resources? And we talked earlier about disruption. You got to watch out here. This is where you could be disruptive. If you have a template that's assigned to servers out there, and you make changes and you come up here and say, we're going to do this with an updating template. So you're going to make these new changes out to the blades. That's where you could have service disruption. Just be aware of that. You know, you might do something through the policy that causes things to reboot, for instance, with an updating template. Okay, so an initial template, obviously there's no one that's going to be following the settings of the initial template, but an updating template, this is going to cause changes potentially out there in the environment, and those changes could be disruptive. All right, so we walk through just making the choices for this particular template. And it's really, you're doing the same. You're doing the same steps that we saw earlier. So let me skip these slides. You don't need to see them again. And what we're going to do is we're going to pick up with a discussion of modifying the template. All righty, I've got the right location. Yeah, keep in mind that after your service policy template's been created, it can be tweaked and modified just like you're modifying a service profile. But now you're modifying an updating template, and it is going to affect all of the things that you tied into this template. So just be aware of that. So, you know, you may have templates for different types of compute. environments, right? In your implementation of your data center, you may have a template for Oracle boxes. You may have a template for SAP boxes. You may have a template for web servers that you deploy in the data center. Notice you've got various RAM setups here. You've got some devices that have no hard disk locally, some that do have a hard disk locally just for swap resources, others that have a local hard disk. You may have jumbo frame support that's needed, hyper-threading support. So again, isn't it nice that we can create these service profile templates to roll these resources out quickly? Okay, how would you create a service profile from one of these nice templates that you created? Well, I'm about to show you. As you might guess, you go into the templates area, you select the particular template that will do the job for you, and you choose Create Service Profile from Template. Couldn't be much easier than that. You're going to go ahead and give your template a name and a number, and you just created, not your template, but your service profile rather, and you just created a service profile from that particular template. So let's just talk again about a potential pitfall here that you want to be aware of. When you're using one of these updating templates, we know this is really a cool way of updating a large number of service profiles that may have been created from it. But remember, the danger is that the manipulation of some parameters will cause all linked compute nodes to reboot, and that could be simultaneously. Yep. So you go in and you mess with the BIOS policy, and you do this through an updating template, you're going to cause a reboot of all compute nodes that were based on that. And yeah, Pete, I agree with you. If you do this outside of a declared service window, then you may have just created a resume producing event. If you go ahead and educate everybody about a particular maintenance window and the data center coming offline, then you're probably going to be just fine. By the way, disruptive changes are going to be notified for you. And notice here, we go in and we update a service profile template, and it says, okay, are you sure you want to do this and reboot all these blades that we're highlighting here? So when we have a service profile and it is bound to a template, then the service profile is read-only, really. Now, if you wanted to go ahead and modify that service profile, notice here you can go in and you can unbind the profile from the template. So that is how you could take your profile and unbind it from a template and make changes. Just like at any point, you could take a profile that you've got in existence and you could bind it to a template. So you would have the advantage of updating all the devices from an updating template. Now, both your service profiles and your service profile templates can be cloned. So we right-click on the service profile or service profile template, and we select from the pop-up menu, Create a Clone. Now what happens is all the pooled identities in that clone will be refreshed with unique values. And a lot of settings, as you might guess, will be cloned verbatim, like the boot order. And then you can go ahead and specify the name and location of where you want that clone to exist, either the service profile template or the service profile itself. Pretty cool. All right. So what are we going to wrap up with then here in Chapter 6? Well, just a couple of odds and ends when it comes to managing our service profiles. Yeah, let's take a look at associating a service profile with a compute node. So we decided not to immediately take the service profile and assign it to a computer. So what we do is, after the fact, we go in and we associate a service profile with a particular node. Here's how you would do that. You go in and you highlight the service profile, and then over on the right-hand side, you choose Change Service Profile Association. And a pop-up says, okay, do you want to do the server assignment through a pool? And you can choose this to begin the association process. By the way, you can observe the events of this process in the fixed state machine monitoring tool inside of UCS. By the way, pretty interesting, there's going to be a little pre-execution environment that boots out on the device itself in order for it to be accommodated with this new service profile association. So obviously you are impacting the compute node out there. Things will happen like the DHCP address will be given, the device will get its universally unique identifier, its MAC address, and all of this stuff happens out there in the computer in the pre-execution environment or PXE environment. By the way, as you might guess, you can go in and you can disassociate a service profile from a compute node. So you would go in and disassociate the service profile. Again, this might be something you want to monitor to make sure it works properly. So you go over to that fixed state machine monitoring tab and you watch the progress as the compute node is freed from the previous service policy. One of the things that's important for us to understand, obviously, is what types of service profile modifications can you make outside of a change control maintenance window. So here we see a summarization of what changes will trigger a UCS utility operating system to run. So pretty cool. Remember, we'll get warned. You don't need to memorize this or anything, but you will get warned. Okay? You will be warned if you have to reboot a system. So any changes you make that are going to result in a compute node being rebooted, you are going to be warned of that particular change. Pete, on the FSM, I think it's, it might be fixed state machine. They told us what that stands for. I just call it the FSM tab, actually. And that's a tab in the UCS that's really handy for monitoring the progress. The FSM tab is great for monitoring the progress of some type of server manipulation. Like, the great example is when you discover a brand new chassis. You know, you add a new chassis with all these blades inside it, you'll want that to be discovered, to be reassociated, and you can watch the progress of that on the FSM tab. Remember, you'll want to plan the organization. You'll want to really plan out the organization, and we know that we are going to have issues if we place things in the wrong organization, because we're going to have to delete them and recreate them in the correct location. There is no way to move objects around in the organizational structure that we can create inside the UCS. So definitely something to watch out for. All right. So how might we move a service profile to a new blade if we've had a blade fail? So here we have a situation where the blade in slot 8 has experienced a severe failure. So an administrator uses the UCS manager to decommission the blade in slot 8. And the service profile that is associated with this compute node is automatically delinked. Great. So right when we decommission in Cisco UCS that blade, the service profile is automatically unlinked. Now, because the service profile gets its server assignment from a server pool, it automatically chooses a new server from the same name pool without any action from you, the administrator. So the service profile reassociates with the new compute node, the operating system automatically reboots, and we have a new and replaced machine up that is just like the previous machine. So service profiles, very, very important, a big, big piece of the unified computing system. And now you know all about them. Great stuff.